Hello viewers, in today's session we are going to discuss some important problems related to Dirac delta function, and in this session we'll solve some important integrals involving the famous Dirac delta function. So let us take these problems one by one. So the first problem is this integral that is from minus infinity to infinity dx, and here we have exponential minus 5 pi I x square, where I is the complex number, that is iota, and here we have delta of x minus 2, right? So we'll solve this integral by making use of the definition of Dirac delta function. So let us call this integral I, and let us rearrange these terms inside the integral sign. So we can write minus infinity to infinity. We can write the exponential e raised to minus 5 pi I x square, then the delta function delta of x minus 2, and here we have dx. So here we'll make use of this definition of delta function, that is integral from minus infinity to infinity. And if we have a function, say f of x, which is associated with the delta function, and here we have delta of x minus a, then the value of this integral is equal to a value of this function f of x at this point, that is x is equal to a. So the value is f of a. So here what we can do, we can assume this function as f of x, and here we have x minus a, that is delta of x minus a. So the value of a is equal to 2, right? So now f of x is e raised to minus pi I x square. So the value of this integral is equal to f of a, and a is 2. So here we have f of 2. So what we will do, we'll substitute a is equal to 2 for x here. So we have minus 5 pi I, and here we have 2 square. So this is e raised to minus 5 pi I, and 2 square is 4. So this is e raised to minus 20 pi I, right? So now to find out the value of this expression e raised to minus 20 pi I, will make use of the Euler's formula, that is e raised to I n theta is given by, or we can take here a negative sign. So we have cos of n theta plus here we have negative sign. So we have minus I sine n theta, right? So we have here for n we can take 20 pi, right? So we have cos of 20 pi minus I sine 20 pi, right? Okay, now see the value of sine 20 pi is equal to 0, because we know that sine m pi is equal to 0, where m belongs to the set of integers, right? So sine m pi is equal to 0, and sine 20 pi is also equal to 0. So this term goes to 0. So we are left with only cos 20 pi. So now the value of cos 20 pi is equal to plus 1, because we know that cos of k pi is equal to plus 1 when k is an even number, right? So cos 20 pi is equal to plus 1. So the value of this integral I is equal to 1. So now consider this problem. So here we have to evaluate this integral from minus 3 to 3, and here we have e raised to 8x minus 5 delta of 3x over 2 dx. So to solve this integral, we'll make use of another important property of Dirac delta function, that is delta of ax is given by 1 over mod of a delta of x, where a is not equal to 0, right? So here if we compare this integral with this one, then we can take this function as f of x, that is f of x is e raised to 8x minus 5, and the limits of integration are from minus 3 to 3, right? And delta of 3x over 2 can be written with the help of this property. So we have 1 over mod of 3 by 2 and delta of x. So comparing delta ax with delta 3x over 2, the value of a is 3 by 2, right? Now mod of 3 by 2 is simply 3 by 2. Here we have delta of x, so we have 2 by 3 delta of x. So now this integral I takes the form minus 3 to 3 e raised to 8x minus 5, and here we have for delta 3x over 2 as 2 over 3 delta of x dx. Now taking 2 by 3 outside the integral, we have minus 3 to 3 e raised to 8x minus 5 and delta of x, right? And see, delta of x can be written as the delta of x minus 0. So now if we compare this integral with this one, then f of x is e raised to 8x minus 5, and our value of a is equal to 0. So the value of this integral is equal to the value of the function, that is f of x, at this point, that is a is equal to 0. So we have f of 0. So now we can write 2 by 3, and f of 0 is obtained by replacing this x by 0. So we have e raised to 8 times 0 minus 5. So this is 2 by 3 e raised to 0 minus 5. So 2 by 3 e raised to minus 5, which can be written as 2 by 3 e raised to 5, right? So the value of this integral is equal to 2 by 3 times e raised to 5. So now consider this problem. Here we have the integral minus infinity to infinity dx exponential minus 3 pi x square and delta of minus 2x. So let us first rearrange the terms. So for exponential, we can write e raised to minus 3 pi x square. Here we have delta of minus 2x, and here we can write dx. So here we have delta of minus 2x. So we can apply this property. So we have minus infinity to infinity e raised to minus 3 pi x square. So our a is minus 2. So we can write 1 over absolute value of minus 2 and delta of x dx, and mod of minus 2 is simply 2. So we can take 1 over 2 outside the integral. We have minus infinity to infinity e raised to minus 3 pi x square and delta of x. So delta of x can be written as delta of x minus 0, and here we have dx. So again, this integral is of this type. So if we compare, then our f of x is equal to e raised to minus 3 pi x square, and the value of a is equal to 0. So the value of this integral is given by f of a, and a is 0. So here a is 0. So we have f of 0. So we can now write half f of 0 can be obtained by taking x is equal to 0 in this function. So we have e raised to minus 3 pi times 0 square. So this is half, and we have e raised to 0 because this entire term goes to 0, and we know that e raised to 0 is 1. So we have half times 1, that is simply half. So the value of this integral is equal to half.